Okay, so this problem says that we have a survey of students, and in the survey it asks whether students are in geometry or Spanish. Okay, so what they found out was that the probability of a student being in geometry was 0.92. The probability of a student taking Spanish was 0.45. And the probability of taking either geometry or Spanish is 0.95. Now, if you drew a Venn diagram of this situation, I'll show you how to solve the Venn diagram, and hopefully it'll come easy to you. But if not, we can always resort back to the formula and solve it pretty simply that way too. So let's draw the first circle, circle G, for geometry, circle S for Spanish. It says that G or S is 0.95. Where would I put that? I can't put that anywhere. G or S would be these three numbers added together, right? But if those three numbers are 0.95, what would be out here? If 95% is out here, is inside, then 5% would be here, right? 5% though is 0.05. Now, a couple of more things is that this says probability of S is 0.45. Where would that go? Which position here? We don't know, right? It's kind of our goal for the people in the Spanish class. Also for the people in the geometry class is 0.92. So I'm going to write something that's hopefully going to be helpful to you. So I'm going to put letter A, B, C. And you guys know that A plus B should equal what? I'm sorry? No. A plus B is this entire circle. So A plus B should equal 0.92. And we know from reading the question that A plus B plus C should add up to how much? This is, 0.95. So now, you see how you have A plus B in this statement up here? And this is still A plus B right here. So I can, instead of writing A plus B, I can write the number 0.92. So 0.92 plus C is 0.95. Now I can solve for this little part here. So we'll subtract 0.92. .03. So 0.03 would be in this section here, which implies how much should be in section B. If that's 0.03 and the whole thing's 0.45, how much should be in the overlap? Just 0.42. And if this whole thing is supposed to be 0.92, but 0.42 is already used up, then how much is this? 0.5. Perfect. Okay? So, when you are asked this question for 4A, find the probability of G and S, then you could write the answer 0.42. Now, was there another way to do it? Absolutely. You could have used the formula which says or equals probability of G plus the probability of S minus the probability of G and S. You just call that X, and then you would be able to solve this linear equation. So this would have given you negative 0.42 equals negative X, which implies that X equals 0.42. Now the next question says, are they mutually exclusive? Well, mutually exclusive events do not overlap. So, are these mutually exclusive?
No.
No. G and S are overlapping events. Now, how do I know? Well, if they were mutually exclusive, then the probability of G or S would equal probability of G plus the probability of S. Well, G or S, we said, is 0.95. Probability of G is 0.92, and the probability of S is 0.45. Clearly, those are not equal. Since these are not equal, then that means that they are not mutually exclusive. And I just use a capital M and E for mutually exclusive. All right, and the last question says, find the probability of G complement. The probability of G complement means everything outside of the event G. If you have a picture, then it's great. All you got to do is put your finger on G and add these two numbers together, 0.03 plus 0.05. However, there is a definition for the complement, which says 1 minus the probability of G is equal to the probability of G complement. So, if I already know probability of G is 0.92, 1 minus 0.92 gives you 0.08. So it's okay if you use the picture and add 0.05 and 0.03, or if you use the formula and do 1 minus the probability of G. All right, so that's about it